Hmm. 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 I have a slight problem.
Whoop! What's the problem, Sciencesaurus Rex?
Oh, hi, Unicorn. My problem is this. I'm really thirsty,
Yeah?
but the water's too low. My face doesn't fit.
Oh, that is a problem.
So, here's the thing. I've got a couple straws,
Right?
but I'm not sure which to use.
Okay.
So, here's what I have. I have a garden hose. This is really hard.
Okay, seems a little inefficient, but sure.
I've got two straws taped together.
Okay.
I've got one regular bamboo straw,
Right.
and I've got two straws taped together really sideways.
Right.
So, if I want to drink a lot of water, which one should I drink with?
Well, the garden hose is a bad idea. I mean, seriously, that's just silly.
Right, but why?
Well, hold on, we'll get there. And the two long straws, have you ever tried that?
Yeah, it's actually really hard.
Right. The normal straw, well, that's how it's designed to work.
Right,
But two straws sideways, that's gotta make it really easy. You'll get a lot of water really fast.
right, but why?
Well, the long straw, you gotta really pull the water so much further. It's kind of hard. It's got a big resistance.
Okay,
And the two straws sideways, well, they're really wide. They let the water through very quickly. It's got a very low resistance.
okay, that sounds like a good idea. But the hose, it's so wide. Why can't I drink through there?
Well, it turns out the hose is much longer than it is much wider. That's going to make it a lot harder. I think we're going to have to look at the math because there's a lot going on there.
Okay, does the fact that one's bamboo and one is rubber and the others are metal matter?
A bit. And that's going to really tie into how electricity works.
Oh? What?
All right, as the unicorn said, we're going to need some math to talk about why things have certain resistances. So we are going to constantly come back to this flow of water analogy. So pretty much everybody was able to think about the idea of length of a pipe, cross-sectional area of the pipe, as two big ideas for what's causing resistance. Obviously, you think about a pipe or a much longer pipe, it's going to be a lot harder to push water through. Same thing with resistance. Resistance of a wire is definitely proportional to the length of the wire. The longer it is, the more resistance there is. Cross-sectional area is a little bit of a tricky idea. Just to picture, same length wire, but we've now made one fatter. What exactly is cross-sectional area? It's this entire area right here. So if I double the radius of the wire, I have not actually doubled the area. I've quadrupled it because pi r squared. The bigger the cross-sectional area, the smaller the resistance. It turns out they're inversely proportional. Now the last one, I asked you guys to talk about copper versus rubber. This is something called resistivity. You can think of it as the difference between a corrugated pipe, or a pipe with rumbly bits in it, and a smooth pipe of the exact same size and shape. All right. Resistivity is an odd thing because it's not really the same idea. It has to do with how the wires are lined up, but the concept works. Resistivity is done by the Greek letter rho. All right. It's got a partner you can kind of think of called conductivity. And that's just the opposite. Resistivity is how resistive a certain material is. Copper, gold, rubber, whatever. Conductivity is the opposite of that, how conductive, how easily current flows. In a material. And these are exactly inverses of each other. Conductivity is in, the symbol for that is sigma. Don't worry about why. They're inverses of each other. We're going to generally talk about resistivity because that's the really interesting one. If we put these concepts together, we get that equation that I'm sure a bunch of you have already seen on your equation sheet. R is equal to rho L over A. So based on that, what are the units for rho? Well, let's think about it. R is resistance. Rho is something. L is in meters. And area is in square meters. So in order for this equation to work out, resistivity is measured in ohm meters. Why? That's why. One thing to watch out for: the American letter P is not the same thing as the Greek letter rho. They are subtly different. Watch out for that. Remember, P is momentum. Rho is resistivity. All right, they are not the same. We'll talk about what the heck this actually means and try some problems with it in the next video.